We're here to discuss system architecture improvements to air conditioning systems. In 1933, a company in New York outfitted vehicles with the first ever air conditioning system. And after nearly a century of optimization, the refrigeration cycle hasn't changed, but the components used, there have been some massive improvements. By utilizing an IHX, this change in structure has been able to reduce the compressor consumption up to 16%. Due to enhancements such as the IHX, the performance of the systems we are going to talk about are going to be considered identical. First, we will discuss a benchmark system, and then we will talk about the proposed system architecture and the system requirements that go along with these two systems. Here is a benchmark AC system. First, let's define what goes into the system. The user gets into the vehicle where the cabin temperature is undesirable, it's too high. So the user specifies what they want the internal temperature to be. Meanwhile, the monitoring function takes the vehicle cabin temperature, the user specified input, and feeds it into the analysis function, where it calculates what the system state should be doing. The system state influences the amount of cooling that is happening inside the cabin. It would change the power to the blower fan or turn it off depending on what is the current state of the system. And then there is a feedback loop that continuously repeats the primary functions in order to achieve the desirable cabin temperature. In the proposed system architecture, the user input is automated. Using the same four primary functions, the system monitors key metrics off of the user and its passengers, calculates a perceived comfort, and that controls the system state. Continuously, our feedback loop is running in order to create a comfortable environment. Using the same system requirements for each architecture, it's easy to compare the two systems. Looking at the differences in ease of use, the user inputs must be intuitive. For the benchmark system, the user puts in the input by hand while driving. It may or may not cause them to look away from the road. In the proposed architecture, this is automated. Safety had been mentioned. The user in the proposed architecture doesn't need to look away from the road, possibly creating a safer environment. In the last three requirements, cooling, robustness, and performance, we expect each system to be equivalent. It should be noted that a perceived comfort level of cooling may need to be increased depending on the user and or passengers. The proposed architecture was designed to make the user experience so simple it's advanced.